Solving equations in radical form. In order to solve equations that have radicals inside, the first thing you must do is isolate the most complicated radical term on one side of the equation first. In this, it means get this radical all by itself on the left-hand side of the equation. So that means I must add the 2 to the other side. So isolating this radical means getting that radical all by itself on one side of the equation. Next, eliminate the radical by raising both sides of the equation to the power of the index. The index is 3. So since this is a cubed root, the only way to get rid of a cubed root is to cube both sides. So cubing this whole side will get rid of that cubed root. But if we cube the left side, we have to cube the right side. So that's going to give me 3x minus 1 equals 2 cubed, which is 8. If there's more than one radical, repeat this and do it to the second radical if necessary. Then solve the equation. This is a basic linear equation for which we now can solve. Of course, you're always going to want to check your answer. There may be what are called extraneous solutions, so you absolutely must check your answers. When you have an answer that is extraneous, it might not check out in the solution. Because sometimes when you square, especially with even indexes, when you square an even index, sometimes you're getting rid of one of the solutions, whether it be positive or negative. So we have to be very careful. So we always want to check our answers. So we're going to put this back up into the original. So we're going to check to see whether the cubed root of 3 times 3 minus 1 minus 2 is in fact 0. So cubed root of 9 minus 1, cubed root of 8 is 2, and in fact 2 minus 2 is in fact 0. So this is the answer. 3 is the only solution. There are no extraneous solutions. Let's try another one. Remember, the first step is to isolate the radical. This radical is already isolated. It's all by itself on the left-hand side. So how do we get rid of a radical? Well, we take it to the power that matches the index. In this case, the index is 2, so we're going to take this whole thing to the squared power. That's going to undo the radical. Now we're going to square this whole side, but that means we have to square the whole side. So this actually turns into a FOIL problem on the right-hand side. So make sure we FOIL all of this. So that's going to give me x plus 1 equals negative x plus 1 times negative x plus 1. When we FOIL everything on the right side, we're going to get x squared minus x plus 1. Combine like terms, x squared minus 2x plus 1. So now we're going to solve this. Since this is a squared, or in other words a quadratic equation, how we solve quadratics back from section 1.2 is we put everything on one side with the positive squared term. So that means I'm going to get rid of the x and the 1 from the left side, and I'm going to move them over here. So I'm setting this whole thing equal to 0. So we have x squared minus 3x plus 0, because those cancel. Now we can use the zero product property. The zero product property states that if we factor either one or both of these individual parts must be equal to 0. So that means either x is 0 or x minus 3 is 0, which means x is 3. So we're going to have two answers. One is 0, one is 3. But of course, we always want to check those answers for extraneous solutions. So we're going to put both of those into the original equation. So let's try 0 first. Square root of 0 plus 1, is that equal to negative 0 plus 1? Square root of 1 equal to 1? Yes. How about when x is 3? When x is 3, we have square root of 3 plus 1 equals negative 3 plus 1. This is square root of 4, which is 2. And this is negative 2. Uh-oh, you can see that we have a problem over here. These two sides are not equal to each other. So 3 actually does not check out. So 3 is not a solution. This is what we call an extraneous solution. So there's one and only one answer to this problem. Let's try one more. Here we've got two radicals, and if you recall back from the explanation, we can only do one at a time. So I'm going to work on the one that's more complicated first. It has more underneath the radicand, so I'm going to isolate this one. So I'm going to add this one to the other side, and we'll deal with it later. So I have square root of 5x minus 1 equals 1 plus square root of x. Now I'm going to get rid of this radical by squaring both sides. So I'm going to square this side also. So that gives me 5x minus 1 equals, and then we FOIL the right-hand side. One times 1 plus 1 square root of x plus 1 square root of x plus x square root of x times square root of x, and we're going to square that. This side becomes 1 plus, combine those two middle terms to make it 2 square root of x, and the square root of x squared, well, they undo themselves, and you're left with x. So now when you look at this equation, you can see that I've managed to get rid of one of the square root symbols, but I still have one more to deal with. Now we're going to redo this whole process over again. This time I'm going to isolate this square root and move everything to the other side. So I'm going to move this x and this 1 over to this side. So that's going to give me 4x minus 2 equals 2 square root of x total. So then in order to get rid of this square root, I square both sides. So this becomes a FOIL problem on the left. And on the right, I have 2 squared, square root of x squared, square root of x squared, the square root and the square undo themselves, and you're left with x. So now you notice at this point, I have no more radicals. So let's keep simplifying. Let's FOIL. 16x squared minus 8x minus 8x plus 4 equals 4x. 16x squared minus 16x plus 4 equals 4x. Since this is a quadratic, in other words, the power is 2, we're going to get everything to one side. So let's subtract the 4x over to the left side and set this equal to 0. So that gives me 16x squared minus 20x plus 4. Now remember, let's recall how to solve quadratics. The first and foremost thing you should always try to do is factor. It's probably shorter than using the quadratic formula, but there is nothing wrong with using the quadratic formula at this point. I'm going to choose to factor. I'm going to try to save a step. I notice that all of these numbers are divisible by 4, so I'm going to take that out first. Then I try to see whether this is factorable. Some of you can choose to use plug and chug. Some of you might choose to use the table method. Some of you might choose to use the A times C method. Whichever method you choose, you're going to find that this factors into 4x minus 1 and x minus 1. Now using that zero product property, that says when two things are multiplied together and the product is 0, that means either the first thing is 0 or the second thing is 0. So that means either 4x minus 1 is 0 or x minus 1 is 0. So I solve for both sides. I find x is positive 1/4 or 1. I don't know for sure if those are solutions yet until I check both of them into the original equation at the top. So that's what I'm going to do next. I want to make sure there are no extraneous solutions. So let's go ahead and check 1/4. If I check 1/4, when x is 1/4, let's plug that into the original equation. So I would have square root of 5 times 1/4 minus 1 minus square root of 1/4, and is that in fact equal to 1? Now this problem might be a little bit easier to do in the calculator, so I'm going to get my calculator out and try this by hand. Okay, so I'm going to put in the square root of 5 times 1/4, and if you'd like to use 0.25 you can, or you can do 1/4 as a division, or you could even do 1 fraction 4 as a fraction. That also works. Minus 1, and then end my parentheses so that way I end that square root symbol. Then we're going to subtract another square root of 1/4. And when I hit equals, I should get 1. But in fact, I get 0. So in this case, 0 is not equal to 1. So that means x equals 1/4 is an extraneous solution. So it is not an answer. We're going to try this again. This time we'll try it with the other solution. This time let's try it with x equals 1. So if x equals 1, let's check it this time into the original. So it's going to be square root of 5 times 1 minus 1 minus square root of 1. And is that in fact equal to 1? This I can do by hand. 5 minus 1 is 4. Square root of 4 is 2, square root of 1 is 1, and it does in fact check out. So that means this is a solution. So I have one and only one solution because the other solution was extraneous.